I'm not going to actually start in the notes today. I want you to start up here with me. What you're going to do with me today is, do I have enough information to say it's a parallelogram now? Okay, so instead of being given it's a parallelogram and using the properties, do I have enough information to say it is? So I want to do a couple things with you. Take a look at these markings here. You think that's good enough to call that figure a parallelogram now? Is that good enough? No, you're right. What else would I need? I need the other pair parallel, right? Good. All right, so we're picking this up. Would that be good enough to say it's a parallelogram? Nope, it's not. Why not? I still need what? The other pair. Good. So we know our properties so far. Ooh, ready? We're going to get a little tricky now. You think that's good enough? Think that's good enough? No, why not? I need the other pair congruent. Opposite, both pair I need. I need both pair. All right, we're doing great. Let me give you one more here. Is that good enough for a parallelogram? Nope. Why not? Diagonals bisect each other, right? I need both diagonals to be bisected to make a parallelogram. And now what I want to introduce to you now is a special case. You may not think it's a parallelogram, but it will be going forward, and that is this. And the same pair parallel. This going forward would be considered a parallelogram. I'm going to refer to it as the special case. Same pair. Hey, I do this. Be careful now. This is not a parallelogram. All right, it's got to be the same exact pair of sides that are congruent and parallel. All right, I'm going to call that the special case going forward. All right, we're not ready for a proof yet. No way are we ready for a proof. So what I'm going to do with you right now, there's 4 different scenarios. Is it good enough to say it's a parallelogram? Okay, be careful if you're using pen because you can't erase your markings, because we're going to use this diagram on all 4. All right, here we go. So first scenario, SPX congruent to TMX. Let's see what that looks like. SPX, TMX. Everybody stop. Don't go to the other pair yet. What type of angles have you just marked congruent? Alternate interior, right? So there should be an extra marking you can put on yourself right now. Go ahead. There should be an extra set of markings because those are alternate interior that you can put on your diagram right now. What else? Oh, those are alternate interior. That means I can put these markings on my diagram as well. And hopefully you're putting on arrows on SP and MT to show they're parallel. All right, look at the other given. TPX, mark it. TPX is congruent to SMX. Hey, what did you just mark there? Vertical. What did we just mark there? Alternate interior. So if those are congruent, put another set of markings on your diagram now. What else can I put? I can put that SM is parallel to PT. Is this a parallelogram? Look at what you marked. Is it a parallelogram? Yeah, that's a parallelogram. So I'm going to put yes. And of course, like every time, now I need a reason. And what we're going to do is flip the reason we always did yesterday. What property are we showing up here? What property are we showing exists up here? I think I did these out earlier. What property is showing up there? Let's start it off. Jared, what property am I showing?
Opposite angles.
Oh, I got these here though. And I'm only showing one pair congruent. I'm not showing the other pair of opposite angles. What am I showing here? Remember, we put these parallel lines up here. Hey, here's what I have, Jared. Take a look. I just put this on my diagram. What property of a parallelogram is that? Opposite sides
are parallel.
Yeah, do we see that? We good? Okay. Opposite sides parallel. implies parallelogram. Notice I flipped my reason from yesterday. You tell me the property implies a parallelogram. All right, let's keep going. Will the next one show a parallelogram? Sx congruent to xt. And then I also have Sm congruent to PT. Is that good enough to say it's a parallelogram? Is that good enough to say it's a parallelogram? Yes or no? Let's keep going here. 219 Cormac, good enough?
No.
That is not good enough. Nope. I either need the other diagonals to get bisected or the other pair of opposite sides to be congruent. Not enough. Everyone agrees? We're good? Not enough. All right, let's keep grinding. Px congruent to mx. Sx congruent to tx. All right, with those markings, am I good enough to say it's a parallelogram? Yes or no? Parallelogram, Vinny? Yes, it is. All right, if it is, what property is showing then? What property is shown here? Who, Drew? That's how I started off now. Diagonals bisect each other, imply parallelogram. We're okay so far. All right, I'll do 4 here with you. I won't call on anybody here. Ready for 4? SP congruent to MT, so we got some hash marks there. And SP is also parallel to MT. Okay, this is our special case I talked about. It. Does everyone see? This is our special case. Same pair, congruent, and parallel. So I'm going to put yes. That is going to make a parallelogram. And if you write down special case implies you will be a special case in here. Okay? That's not what we write down. We're going to write down one pair of opposite sides, because that's what I have. One pair of opposite sides, congruent and parallel. All right, so that's what I want to write down there. One pair of opposite sides are congruent and parallel, and that implies a parallelogram. So special case can work going forward, but it's got to be the same pair. I'm going to keep harping on that. Same pair. All right, you have 8 potential parallelograms below. I just want a yes or a no. Don't write the reason. I want to save some time. All right, I want to save some time so you can work with people in your group on your own. I'll give you about 2 minutes. Are these 8 quadrilaterals parallelograms or not? All right, and don't worry about an explanation. But if you get called on, I will have you explain why. All right, are we a parallelogram or not? And if you're going to tell me yes, I do need a reason. All right, I know I didn't have you write it down, but just tell me a reason. All right, first one up. Lauren, parallelogram and number 7?
Yes.
Why?
Diagonal.
Darn right. Diagonals bisect, so that is a parallelogram. 8, is that a parallelogram or not? Jared?
No.
Nope. Need more, right? I would either need the same pair parallel or the other pair congruent. 9, good enough for 9? Zoli?
No.
Nope. Markings aren't in the right spot for me. All right, they're not in the right spot. How about 10? Good enough for a parallelogram here. 10. Jared, back to you.
Which one?
10, parallelogram.
Yeah.
Why?
Because it has both sets of congruent lines opposite.
Yep, there you go. Opposite sides congruent. All right, number 11. Hopefully you added some own markings on for 11 based on those angles being congruent, right? Hopefully you marked, right? If these angles are congruent, that means something else is happening in the diagram. So is this a yes or a no here for number 11? Zoli?
Number 11, yeah.
Yep. Take a look. If these angles are congruent, the lines are parallel, so opposite sides parallel. Okay, you gotta look. Alternate interior angles make parallel lines. 12, good enough here? Choose. Lauren, back to you. Nope, need the other pair. Need both. 13, good enough. 18, not here. Going again. How about 9? Vinny, good enough?
Yes.
Yes, why?
One pair of opposite sides equal or congruent parallel.
Good, thank you for not saying special case. 14, good enough. Drew, back to you.
No.
Nope, need them both. Congruent. All right, I think, ready or not, we're ready to start tasting a little bit of a proof. Proving it's a parallelogram. So I wrote all the givens in so you can mark your diagram, and then just a fair warning, I'm going to start yelling here in a second. All right, 1 congruent to 2, and 3 is congruent to 4. And we have to show why it's going to be a parallelogram. All right, here's where I'm going to get fired up. Look in the givens. What is the only thing you know about PQRS? It's a what? Quadrilateral. That means no properties. The only thing we know about a quadrilateral, 4 sides. Good luck using that in the proof. All right, so don't just, oh, it's a quadrilateral, opposite sides congruent. The angle, no, stop. Stop being embarrassing. All right, it's a quadrilateral, no properties exist. That's it. All it's telling you is this darn thing has 4 sides. Okay, so don't get all happy when you see quadrilateral. It's useless, useless. But we do know 1 and 2 and 3 and 4 are equal. And going back to you guys, what type of angles do we have marked congruent up there in 1 and 2 and 3 and 4? What type of angles are those? Cormac? Yep, and if they're congruent, I have parallel lines. All right, so in step 2, all right, somebody new, tell me what lines are going to be parallel then. Ooh, going someone new, Alyssa.
PQ and SR.
PQ, parallel to SR, and also, give me the other pair.
PS and Q.
Yep, and I can put this in the same line because we're going to use the same reason. PS and RQ. Good job. All right, what are you going to put? You're not writing parallelogram implies. We don't have one. We're trying to prove it, remember. So don't start this off with parallelogram implies. How do I know those lines are parallel? Talk to me. How do we know? Vinny, back to you on fire today.
Alternate interior angles congruent implies opposite sides parallel.
You don't need to say, you can just say alternate interior angles congruent imply parallel lines. Done. All right, you don't need to get fancy on me. And now, do I need to say more, or is this already a parallelogram? Is it a parallelogram right now? Yes or no? 20 spot here. Brendan, is this a parallelogram?
Yes.
Yeah. So step 3, tell me it is. We're done. PQRS is A. And again, if you want to use that symbol, fine, but it's only reserved for parallelogram. And what property makes it a parallelogram up here? What property are we showing? Oh, 0 for 2, 0 for 3. Brendan, back to you. What's the property we showing?
All the pairs of parallel lines are.
What's that mean? You might as well just said that in German and mean the same thing to me. What's showing up here? What did we just show?
Parallel lines.
Okay, well, what about opposite?
Oh, opposite sides are parallel.
There you go. Now we sound like we're in this class. Good. Opposite sides parallel implies a parallelogram. Yeah, that's nice. 3 steps. I wish that could all be 3 steps. We're done with that though. All right. Now to our AB level 1. And this is why you have the colored pencils with you. Relax, relax. He just says colored pencils. That means I pick them up. Not really. Why do I have the colored pencils? You are given a parallelogram and you need to prove one. So the colored pencils are going to be used for, all right, I'm going to highlight one of the given one in a certain color. So I know when I highlight A, B, C, D, I can use all my properties on that one. And then there's also one in the proof statement. I'm asked to prove EBFD is a parallelogram. So just make sure you know what color belongs to the given parallelogram and what color belongs to the one you're trying to prove. Because you can use properties on one and not the other. And also the other given we're using is AE congruent to CF. Okay, so remember the big one, whatever color you shaded that in, is a parallelogram. We can use properties on that one, but we cannot use the properties on the one on the inside. All right, let's do this. So the one on the inside, we need to get some congruent sides, maybe parallel sides. All right, this one on the inside, EBFD. Can you get me a pair of sides maybe congruent to start us off, or maybe sides parallel? Is there anything you can do here? Help me out. Is there any sides you can get? Probably we can start with congruent. Is there any sides there you can get congruent on the one on the inside? Hi, Alexi. AD and BC. How are you going to get those? They are, but remember, we're trying to get something here. We're trying to make this a parallelogram. Right? What's that? Addition with what? DF and... Okay, hold on. I think we're getting confused here. Which one are we trying to prove is a parallelogram? EB and FD. So I need sides in that one to be congruent or parallel. So I need this right here. I need you to get me this somehow. I need maybe you to get me this somehow. Okay? But I can't say, oh, they're congruent because they're opposite sides. It's not a parallelogram yet. We're trying to prove it's a parallelogram. Okay, so how can I get sides or angles in here? What's up, Selim?
Subtraction.
Okay, with what?
So the ABCD, the sides, so DFC.
Okay, so here's where we're going to start. DC is congruent to
AB.
AB, and we're going to subtract the givens from them. Does everyone see how we're going to get a pair of sides in that parallelogram we're trying to prove? Okay, so let's start there. Good start. DC. Can't go to subtraction right away. I need the big pair congruent. DC congruent to AB. What are you going to write in your reasons for that? Now we're going back to today and yesterday. We're flipping back and forth. Got to keep things straight. Why is DC congruent to AB? What are we going to write here? Shara? There you go. We're going back to yesterday now. Parallelogram implies opposite sides congruent. And now you can do your whole subtraction substitution. So we can say AB minus the given AE equals DC minus the given FC or CF. And then substitution. To say DF and EB now are congruent. Good job, everybody. Good job. Okay, let's see if we really know what's going on now. See if you can answer this for me. See if we really know what's going on. Okay, here's what we just proved. EB congruent to DF. Is that a parallelogram right now? No, I still need to keep working. All right, what would make it into a parallelogram? What other additional information would make that into a parallelogram? One thing, Cormac.
The DF and EB
Okay, if somehow as a group, we could prove DF parallel to EB, that'd be my special case. Is that the only way? Or is there other information that would make, let's say, okay, we don't do that way. Is there anything else that would make it into a parallelogram? Simon, go. Prove the other pair congruent. If we could do that. We can do both. I am just going to do one as a class so I can show you a couple new facts. What Simon just suggested can be done by proving those triangles congruent and saying CP, CTC. I'm not going to do that way, though, but it can be done that way. Does everyone see? You could do side, angle, side, get them congruent, and then say CP, CTC. All right? I'm not going to do that way. I'm actually going to do Cormac's way, and I'm going to show you the lines being parallel. Okay. All right, so how in the world am I going to work this magic to get DF and EB parallel? I'm going to show you a new fact that you can use going forward. We said in step 2, DC and AB were congruent. They're also what? DC and AB are also not only congruent, but also? Okay, let's write that down in step 5, and I'll show you where I'm going with this. DC is also parallel to AB. Parallelogram implies opposite sides parallel. Okay, so where am I going? How does knowing they're parallel get me DF and EB parallel? Here's why. Take a peek, kids. Take a peek. Take a look at those suckers. I'm going to tell you they're parallel. You answer a question for me. If those are parallel, are those smaller pieces parallel? How about those pieces? Still parallel? Oh! How about those little ones? Are they still parallel? Yeah. What am I getting at? Take a look back at your diagram. Don't do this. Not at this time. I was ready just to... It's going to take a lot for me right now just to not flip this thing. Just totally blew everything. Okay, we'll go back to calm now. You just told me A, B, and CD were parallel, right? Shouldn't EB be? Shouldn't these little pieces be parallel too? Yeah, so that's what I'm going to write right underneath it. And let me just rewrite DC parallel to AB. Sorry, that didn't save, I guess. Parallelogram implies opposite sides parallel. So if the big pieces are equal, so are any segments on them, including DF parallel to EB. And here's your new fact going forward you can use. If the whole things are parallel, so are the parts. Parts of parallel lines are parallel. You can only use these for parallel lines. Don't use them for congruent. You can't say the parts are congruent. And now we have a parallelogram. EBFD is a parallelogram. And I'm going to ask somebody why, and don't say special case, right? I want to just make sure we get the wording correct. Oh, Stephanie, here we go. Why is this a parallelogram? Again, let me mark my diagram. we had these were congruent by subtraction, and now these are parallel by being parts of parallel lines. So overall, why is that a parallelogram? What's that? What do I have marked? Just a pair of opposite sides. Go ahead, tell me the rest. I didn't hear it. A pair of opposite sides. Yep. I need more though. No. Hey, this is what you're telling me right now. A pair of this is what you're saying right now, Stephanie. That's a parallelogram. A pair of opposite sides congruent. We did congruent and also did what? And parallel. So we got to write the and parallel part. And parallel implies a parallelogram. Because just being congruent wouldn't be good enough. Okay, flip it over. One last thing. We just learned a new theorem, right? If the whole things are parallel, so are the parts. We can use that going forward. Parts of parallel lines are parallel. Remember, do not substitute in the word congruent. It doesn't work for congruent. Well, what happens if you know the parts are, but you want the bigger pieces parallel? I can't use this anymore, right? So on our proof here, if you knew DF and EB were parallel, but what if I wanted AB and DC, the bigger parts? Instead, we don't use the words part, we use the word extensions. Extensions of parallel lines are parallel, all right? So if you want the bigger pieces parallel, use extensions. If you want the smaller ones parallel, use the parts. All right, get rolling, get going.